Exponents. Now, what do you mean by an exponent is the first question. Many times you might come across cases where a particular number might be multiplied by itself. So let's say you have 3 times times 3. Okay? And when you calculate this, you get 27. Right? Now, whenever a particular number is multiplied by itself, any number of times, please note that the number has to be same. It's 3 all around. Or let's say you could have had 2 into 2 into 2, which is equal to 8. Or let's say 4 into 4 into 4, which is 64. In such a case, you can also write this detailing, and this can go up to any number of terms. Let's say 3 can get multiplied by itself 100 times. You write it as 3 and another 3. So this 3 is basically known as the base, and this second 3 is also known as the power or exponent. And you read this as 3 raised to the power 3. Right? So 3 here is known as the base and 3 is known as the power of the exponent. Now there are certain rules through which these exponents play. When I say play, I don't mean they are literally playing with each other, but the way they work out. Okay? So the first rule is that if you write 2 to the power 3, this basically means 2 into 2 into 2. Or you write 3 to the power 5, this means 3 into 3 into 3 into 3. So basically, whatever is the power, it means that this particular number has to be multiplied by itself that many number of times. Okay? Let us also see some basic rules about these numbers. So let's say you have 3 to the power 3 multiplied by 3 to the power 5. Right? So this basically can also be written as 3 into 3 into 3, which basically represents the first part, multiplied by 3 into 3 into 3. So you have 3 5 times. Okay? So this 3 upon 5 can be written as this can be written as this. But hold on. If you notice, effectively what is happening here is 3 is being multiplied by itself 8 times. Right? 1, 2, 3, 4, 5, 6, 7, 8. So in that case, we can also write this as 3 to the power 8, because 3 is the number which is getting multiplied by itself, or the base, and 8 is the number of times 3 is getting multiplied by itself. Right? But if you notice, 3 to the power 8 is nothing but 3 to the power 3 plus 5. Right? Which is this. The powers are being added. So we generalize this by saying for any number a into n into b to the power m, into a to the power m can be written as a to the power n plus m. So with the same base, you can add on the powers where these two numbers are being multiplied by themselves. Right? Similarly, if suppose you had a to the power m to the power n. So let's say you had 2 to the power 2 raised to the power 3. So what does this mean? If you take a is equal to 2 square, this means that we effectively have what? A cube over here, which means what? A into A into A, right? or 2 square into 2 square into 2 square, right? But from here we notice that a to the power n into a to the power m is a to the power n plus m. So we can write this as 2 to the power 2 plus 2 plus 2, or 2 to the power 6, right? Again, interesting. If you notice, 6 is equal to what? It is equal to 2 times 3, right? So we write this as a to the power m raised to the power n is actually equal to a to the power m into n, right? Let's just write it here. Okay, so these are some of the rules of the exponents which are applicable, right? In this very example, if you notice, if instead of a to the power n into a to the power minus m, so how does it fare out? Again, the base is common, so we take it as this. Of course, if you have same base, different multiples, you add them, so n plus minus m, or simply n minus m, right? So now we are going to see certain examples on each of these formulas, or whatever you might call them. Okay.